as promised, these are the notes on trophic levels. Alright, so troph means nourishment or food. So an ick, as we talked about, means having to do with. So trophic levels have to do with the feeding position in a food web or food chain. Every food chain and food web has to start with a producer. Down here at the bottom. Okay, here you got the producers. And then the producer gets eaten by something. The first thing to eat it is called a primary consumer. And anything that eats the primary consumer is called a secondary consumer. Right? And so forth and so on. Okay? Tertiary means third. Quaternary means fourth. All right? So that's the basics. Okay? Now let's move on. All right? So if we look at this diagram, okay, the snakes are blank consumers. Well, here's the snakes. I don't know if there's the snakes, right? And so they are a consumer. These are consumers and these are consumers. These are producers. So the snake is the primary, secondary, tertiary consumer. The grasshopper, all right, so they are in the first set of consumers. So it's a primary consumer. Where's the most energy? The producers are always going to have the most energy and the most biomass because they're the biggest part of the triangle. That's why they're at the bottom of the triangle. Okay? Where's the most biomass? The producers. Okay? Now, if a question asked you quaternary or tertiary, which one has the most biomass, then tertiary would be the answer. Okay? But if they just ask in general, it's always going to be the producers. How much energy is passed up from one trophic level to the next? All right, we haven't talked about this before, but it's 10%. 10% gets passed up from one energy level to the next. And the reason that is the producers just have to photosynthesize, right? So they get their free energy from the sun, they photosynthesize, and they grow. The grasshopper, it has to get to the grass, has to eat the grass, that takes energy. It has to digest the grass, that takes energy. It has to escape predators, that takes energy. It has to find mates. It has to, some of its energy is lost as heat. That happens even in cold-blooded organisms. Okay? So all of this energy is being used by the organism or lost as heat. So only 10%, if you want to think of it as like profit, the grasshopper only gets 10% energy profit from eating the grass. Now, let's say this rat up here eats the grasshopper. Well, the rat also has to maintain its body temperature. It has to digest the grasshopper, has to catch the grasshopper, has to avoid predators. It loses energy as body heat, right? So the rat is only going to get 10% of the grasshopper's energy profit. So the rat gets 10% of the grasshopper's 10% of the grass. Okay? And then the snake that eats the rat only gets 10% of the rat's 10%, of the grasshopper's 10% of the grass. And if there's a quaternary, it only gets 10% of the snake's 10%, of the rat's 10%, of the grasshopper's 10%, of the grass's energy. Okay? So that's why it's a pyramid. As you go up, it gets smaller and smaller because there's just not enough energy, okay, to support a lot of numbers. So you have less biomass at the top because there's just not enough energy to go around. The hawk can't eat the grass. Right? It can eat the snake. It might even eat a rat if it catches one, but it's losing energy. All right, so here's the answers. All right, so we went through over all that. Now, this is a time lapse. I just want to show you real quick. So what you have, this is a time lapse, so it's sped up. And you have these waves coming in, okay, probably during high tide. Now, you see that as the water is receding, so that means high tide is going out and it's becoming low tide. But notice how in these rocks, there's little puddles of water. Those are called tide pools, okay? And now high tide is coming back in, and the area is covered with water again. Okay? So, and then eventually, that high tide would go out, and the rocks would be submerged, but there'd still be those pools of seawater. So, when we talk about the intertidal zone, that video was of the intertidal zone. All right, moving on. This one, I think the guy just wants to show off his camera, so we're going to skip over him. But these are tide pools. So these are some of the things that live there, okay? And they have to be underwater, most of them. Some of them, like maybe a clam or something, they can probably close up. The snails could probably go inside their shell and survive a little while outside of the water. But generally speaking, they need to be in water, like a sea anemone. Okay, but these are tide pools, and they are really cool little, very small ecosystems. And that's a hermit crab. He's going for a walk. All right, moving on. All right, so once again, you're copying down the yellow. So trophic levels and energy. Okay, as we said before, the arrows show where the energy is going. So it's always going to point to the thing that is getting the energy. The only time an arrow would point at a plant is if it's pointing from the sun to the plant. I guess there might be some cases where you have a Venus flytrap, but you're usually not going to see that in a food web on a state test or a test I give you. Okay? Energy is passed up the food chain. When one organism consumes another, it gets energy from that food. And that's why we eat, is to get energy so we can survive. Okay? But only 10% is gained by the consumer. Right? The other 90% is used to keep the organism alive or lost as body heat. Let's see here. So that's why there's usually only 4 trophic levels. We talked about that before with the diagram. Okay. Trophic levels in biomass. With less energy at higher trophic levels, there are usually less biomass. Okay. There's just not the energy for it. A hawk that eats a snake gets 10% of that snake's energy as profit. So it has to eat quite a few of them. And then if there were 1 million hawks, there just wouldn't be enough snakes. So that's just the way it's designed, evolved, whatever you want to call it. That's the way it works. All right. Pause if you need to copy. If you're still copying, I'm going to move on to keep the video short. Okay. Energy pyramid. So an energy pyramid is like a trophic level pyramid. But with the energy pyramid, it shows you the energy flow. So shows the energy at each trophic level and the loss of energy as you move up. Energy decreases as you move up the trophic levels because of waste creation and the conversion of energy into heat. Okay. 10% is transferred as you move up from the sun. So, for example, if a producer stores 1,000 units of energy from the sun in their biomass, then the primary consumer, like a grasshopper, would only gain 100 of those units. Remember, the grasshopper can't make its own food. It is relying on the energy from what it eats from the grass. Okay? Now, a secondary consumer, like a rat, comes along and eats the grasshopper. It only gains 10 units of energy from the rat. So it's 10% of 10%. And a tertiary consumer would only receive 1 unit of energy from eating the rat. Okay? So as you go up the trophic levels, there's less and less energy available. All right. Producers bring non-living energy from the sources like the sun into the food chain. That's the function of producers. They take non-living energy and turn it into usable energy for the food chain. So they take energy from, and no energy is alive. That's, maybe I shouldn't have worded it that way. But they take energy from the sun, or in the case of chemoautotrophs, they take energy from chemicals and turn them into usable energy. So your example could be an oak tree, or a cypress tree, or grass, or a strawberry plant, or a rosemary bush. Okay? Now the primary consumer is usually an herbivore or an omnivore that eats the producers. Okay? But a primary consumer in a food chain is always going to eat the consumer. So if it's an omnivore, like say a rat that might eat grass, or it might eat a grasshopper, it would be a primary consumer when it ate the grass. It would be a secondary consumer when it ate the grasshopper that ate the grass. That's where you get into food webs. The secondary consumer eats the primary consumer, and the tertiary consumer is usually the top. They eat the secondary consumer. If there is a fourth or quaternary consumer, it would eat the tertiary. So it's literally producer 1, 2, 3. All right. So pause the video here and take a look at these questions and try to answer them. And try to answer them all before you unpause the video and look at the answers. Alright, so go ahead and pause now. Alright, welcome back. So let's check out the answers. Organisms that make their own food are autotrophs. Organisms that eat other organisms are heterotrophs. If there is 5,000 joules of energy in the primary consumers, how much is passed to the secondary consumer? 500, okay, because that's 10% of 5,000. What percentage of energy is passed up the food chain? 10%. What happens to the rest of the energy? It's either used to keep the organism alive, to make waste, or it's lost as body heat. Sunlight is abiotic. It's not a living thing. Hookworm that feeds on stealing food from the host's intestines is a parasite. That was a throwback question. Alright. And then I think we're going to stop there, and I'm going to take some of those videos that I just skipped over, and I'm going to turn those into assignments. And the next lesson will be on biogeochemical cycles, like the carbon cycle, nitrogen cycle, oxygen cycle, water cycle, all that good stuff. All right? So I'll see you next time. Stay curious.